Today we're going to be doing some reverse engineering. This is going to be on the Game Gear VA4 and 5 versions called the Majesco. This is something we didn't really get in the UK. I've never even seen one before until I had somebody send me every version that they have locally. Whereas in the UK we've done thousands of Game Gears and never really come across them. So I don't know much about them. I've made a clean screen for them so I know how the LCD works. But we don't know anything else, like how the red light boot circuit works, how the games load. And a customer's sent in two that don't work and don't have red light boot. So I'm going to reverse engineer these now and see what knowledge we can gain based on the customer's faulty one and my working one. So we've got the customer's VA4 here. They've also sent in a VA5 for similar issue. I think this is the VA5. And we've got notes of the issues, which are quite extensive, but if I break it down for you, the VA4 we're working on here did seem to have a working system initially. It sounds like it booted with sound, and then after simply working on it a bit, it lost red light boot. Similar thing happened to the VA5. So basically we know this was originally okay, but now we don't get the red light boot. Because this isn't exactly the same as the VA0 and 1s, and the pinouts are different and the circuit's different, we're going to have to do some reverse engineering. And just before we get working on the US Game Gear, I've got some support from Canada. So this is from Video Game Restoration, VGR. We've worked together on TikTok since I started, and we communicate all the time and help each other. He's kindly sent me what looks like an awesome t-shirt, and some chocolate, ooh, and some hardware. This will be the GameCube lid sensor. That's cool. I'll do a separate video on those. And oh yeah, we got lots of stuff, so I'll keep all this lot for another video. And this is the t-shirt. That's pretty cool. So if you don't follow him already, I'd definitely recommend it. Ooh, salted caramel, coffee crisps. That'll be one of my favourites. But before I get too distracted, let's jump on some actual repair. So I think where we'll start is on the ASIC. If we look on retro6.wiki and we presume it's a one chip, that's the best knowledge we can have right now. We're going to presume most of the pinout is the same as this. And if we go to Math's website as well, syf.nl, he's also done some reverse engineering on the VA45s with the pinouts. And if we compare them, like pin 1 is 5 volts, we can see pin 1 on the VA01s are 5 volts. And if we do, say, the VREF here, it looks like he has traced this back. Pins 83, 4 and 5 do match here. So we can use both of these resources and kind of make some judgment calls. And let's start with the VREF circuit, presuming it's just the same. And to make this process easier, here's my tub of every known VA4 and 5 model. So you can see I've got them all labelled. This come from one of our customers, very kindly sent all of these to me to help me effectively get the clean screen working. And I think that's the one we want. 9537. 9537. So we want to use this one. We have the customers here. If we turn on with the clean juice, we get no red light. And we have the version I have that should work. And if we turn on, we get red light. So we can use this as the base to figure this out. The traces for the signals run under the ASIC and then to the back of here. And I don't believe anyone's got a photo of this yet. I know Matt's done a photo of the VA5, but because we need to see under here, I'm just going to take this ASIC off. With the ASIC off, we can see the traces run along here, down to these vias, and then when we flip over, I've had to also remove the work RAM because they go to here, they come out, go to these 3 vias, come back up at these 3 vias, run along here. We get these 2 points here that go somewhere else, and VREF goes to M3 and out here. If we continue that on, we now know that VREF goes to R68, and the left of R68, tracing it, should go to VREF. Following the other traces, you can see I've belled them out from here, down to here, then they go across to here, and they go into this resistant network here. And if I use my known good working one to do all the continuity tests to prove that, I've now made a full map of where all the pins go, or where they should go, and we're presuming it's got the exact same network as this, and from what we've just learned, it definitely does. The M3, 4 and 5 test pins are the same. There's 3 resistors. I haven't looked if there's a diode or a cap yet. Using the working one first with the power on, if we measure this resistor, we get 5 volts. We go then to this pad here, we get the 1.5, and then this pad here, we get the 1.1. Those go over to the ASIC pins over here, with VREF being pulled to ground by the clean juice. VRES for V reset is the 1.5, and the V on off is the 1.1. Let's compare that now on the customer's board. We'll start with the 5 volt resistor here, and we're getting nothing. So that should be coming from VBAT, which is 5 volts. So we must have a broken trace from VBAT to this resistor. We'll fix that first. And checking continuity, it's this via right here that's blown out. So when the customer's changed the cap here, this via that goes to the other side of the board here no longer has continuity. There's the repair done. So I've popped a tiny wire through the via and soldered it the other side. So now we should have continuity. Testing again on this resistor now. We get the 5 volts we should. On here, we get the 1.5 volts that we want. And on here, we get the 1.1. So, are we in red light boot yet? Yes, we are. We're in low battery, which may be the case. I'll have to check the battery. But checking the V on off, which is the low battery, indicates 0 volts. So it's another broken trace from here through to here. And that break has happened on this via here. So from here to the other side is broken. So it's near this cap, which may explain it, but you wouldn't expect it to really be broken. With both of them now restored, both traces were actually broken. So I've gone straight back to the source before it goes to the ASIC. That's sorted out the connections. But now we get a short from R25, which we can see if we measure the resistor. It seems to be shorting. Lifting up and moving the resistor to the side revealed a slight hairline short under there, possibly caused when this cap was being soldered on. And now with them two done, we finally get a stable red light. So it does look like the entire circuit is just the same as the VA0 and 1s, and you can see where the traces run. They go from this chip to these 3 vias, run all the way along to the board. VREF goes up to there, and the red light boot circuit's here. And as always with everything I do, there's now a VA4 section on the wiki with all of this info now written in, as well as test points. I do all this for free, so if you do want to support me, you can feel like donating or voting for the next product that you want us to make, or just purchase something off the site, and that keeps everything going. I'll fix the VA5, hopefully in the same way, and add it to the wiki. And we can see it does load Sonic Drift, so we've got audio, and the customer can now get back to fitting whatever he wants into this.